So let's start with the concept of softmax activation function. See, this softmax activation function, like other activation function, they are mathematical function. And what it does, see, it basically performs some conversion. Means it is basically used for converting a vector. Means we can say that if you have number of inputs or if you have vectors of numbers, then it will convert all those vector numbers into vector probabilities. This thing is something new. So the main objective of this softmax function is converting vector numbers into vector probabilities. So this thing you have to keep in mind. But see, in order to understand softmax function, you have to understand other functions which are known as max function, arg max function, and then only you can realize what is the meaning of softmax function. So let's start with max function, then we will discuss about argmax function, and then we will talk about softmax function. And I'm not going into the theoretical details. You just have to see the code. So whenever I am talking about max function, so what is this max function? You have to keep in mind. Pay attention to this code. Though it is a very small code, but it is one of the most significant code. See, max function means the maximum or the max mathematical function, means it returns the largest numeric value for a list of numeric values. So what is the output? See, we have one data list 132 and it is returning 3 because it is a maximum number. So it's a simple thing. So the output is 3. So what is new in it? Now pay attention to this. Now, if I design argmax function, means instead of max, if I write over here argmax, then what will happen? This argmax function is again a mathematical function, but see what is the output. I am using the same data list 132, but argmax is returning 1. Now the question is why? See, basically this argmax is returning the index of the largest value. Means you can think of it as a meta version of this max function. Means max function is sending you the highest number. However, it is sending the index of the highest number. So here this is the 0th index, this is the first index, and this is the second index. And see here, this argmax function is returning 1, means it is returning the index of the largest value. So that's why argmax function is considered as meta version of the max function. But what is our topic of discussion? Our topic of discussion is the softmax function. But while defining softmax function, we have to try out all this, means we have to decode the output also. So whenever we are talking about softmax function, try to understand it is converting vector into some kinds of probability. So what is this concept is all about? See, I am just implementing the same list, that is 132. So this is the data list I am using. So if you consider this data list, this one 132, in the probabilistic perspective, so the argmax function is returning 1, that we have already discussed. Now, consider whenever we are using the same concept using some new kinds of mathematical approach, means how the concept of probability can be achieved in this simple logic. See, one thing we can do, we can perform scaling in the values. That is, if we impute the concept of scaling, we can get the probabilistic approach. So what is this? See, probability means, first I'm showing you the concept. If I am talking about some kind of probability, then what we have to do, we have to deal with some exponential values, means we have to perform some kind of scaling. Scaling means exponential value divided by sum of some variable in the list, and then exponential value of this variable. So here max and argmax, they are dealing with a particular list of value, something like this. And here softmax is not dealing with the value. Softmax is dealing with the input vectors in order to convert it into some probabilistic concept. So basically softmax uses this concept. Means whenever we have some inputs and we have the activation function as softmax, then it will use this kind of calculation. Now how it is performed? So I'm giving you this simple idea. So this is our list 1, 3 and 2. So if I'm using max function, the output is 3, the highest number. If I'm use argmax, it is giving the index value of the highest number, that is 1. And now see how softmax works. See, for an example, say we are considering this value 1 and I'm using softmax function. So in the list 132, how we can convert this value 1 into probability? Then we will convert this 3 into probability, and then we will convert this 2 into probability. So let's check this one. How this 1 is converted to probability. So then we have to write probability is equal to which value I want to pick? 1. So I will consider exponential value of 1, then divided by sum of. Sum of means here I have to calculate exponential value of 1, this one, plus exponential value of 3, this one, plus exponential value of 2. So by calculating this thing, we will be able to find the direct converted form or the vector probability for this number. So exponential of 1, if you calculate, it is near about 2.7 something. So you just go and calculate. And if you calculate this part, exponential of 1, exponential of 3, exponential of 2, I have calculated it previously. So it is giving near about 30.19 kind of value. And then by dividing this thing, you will get near about 0.09, this kind of value. So this is how this 1 can be converted to probability. Similarly, you can apply this concept to 3, and then similarly you can apply this concept to 2. Now see, whenever you have 1, the probabilistic output is this one. Now see the output. See, whenever we are using these numbers, or I have already given you this one. So whenever you have 1 over here, so what is the output here? See, it is 0.090, and now you can understand from where this value is coming. This 1 is converted to probabilities by calculating exponential of 1 divided by exponential of 1 plus exponential of 3 plus exponential of 2. Similarly, how this value is coming? So again the same formula is applied for this, and how this value is coming, it is getting this. So this is how this softmax function will work. So now see, here is one output which is 1.0. So now we have to consider one more thing while dealing with softmax. See, softmax works on the concept of giving weights, means it will assign some weights to some particular index, means it will assign weight in order to replicate more importance to some value. So among 1, 3, 2, see, the more important value is 3 for our case, for an example. So it will try to assign maximum weight to the 3, or that is the maximum weight to the index value of 3. So now we have to understand the concept of maximum weight assignment. Then only we can understand what is the meaning of this 1.0. So here also you are getting the same answer, that is, after getting the probabilistic output you are getting 1.0. See here what we are doing. So finally we are using softmax function which is coming from NumPy. In order to calculate softmax function, an array of list we have considered. Now we have to understand one simple example in order to understand softmax function and the weighted concept. Also, I will discuss the concept of one hot encoding over here. See, for an example, consider multi-class classification problem. Means we have more than two classes in our input data. Means more than two class labels we are having. So we have to prepare the data accordingly, and the target variable will contain the class labels. I don't know how many classes should be there, so we can expect that we may have 0 to n minus number of classes. And here n denotes the number of class labels. Right? So we are dealing with multi-class classification. Now, whenever we have the class labels, in case of Irish, we have Setusa, Versicolor and Virginica. So whenever we have categorical class level, they must be encoded. Encoded means they must be converted to integers. So we can name Irish Setosa as 0 class, Versicolor as 1 and Virginica as 2. So this is how multi-class class levels are encoded into integers, right? So we can apply this thing up to n minus 1 number of classes. So now here you have to consider this thing. So basically we are talking about when we have three class levels. So we can say that we have class 0, we have class 1 and we have class 2. So why I have considered three value of classes? Because it is a multi-class classification problem and we are expecting more than two classes. Fine. So here, see how this integer encoding is performed. So whenever we have class 0, say it is written as 1, 0, 0. Say whenever I am having class 1, say it is written as 0, 1, 0. And whenever I have class 2, it is written as 0, 0, 1. The question is why? See, class 0 means the first class. So that's why 1 is here and rest of the two classes are 0. Class 1 means the next class. So I'm not talking about the first class or I'm not talking about the last class. So it is a second class. So that's why 1 is here and 2 means the third class, third kind of category. So that's why 1 is here. So this is how this encoding is performed. So basically it represents the expected means multinomial probability distribution for each class, which uses the correct number of model under supervised learning. So it's a simple thing. So this kind of coding we can expect. Now see what we are doing. Means we are talking about weight assignment. So for an example, say if the integer encoded class 1, say we are talking about integer encoded class 1 and we are expecting to give some weightage to this class 1, say for an example. So this class is 0, 1, 0 class. So now how this softmax output will look like. So if I apply softmax activation function and by using this activation function, my objective is to put more importance on this section. If this is the input, then the output will look like say 0.09, 0.66 and 0.24. See, I am giving maximum weightage over here. Means the error between the expected and the predicted multinomial probability distribution is calculated over here. So some kind of cross entropy is also used over here. So the concept is very simple. So the consideration means after visualizing the output of the softmax function, like this, you can also interpret that which portion has the maximum weightage applied on it. So it is 0.09, it is 0.66, it's 0.244. That is maximum weightage is over here, that is 0.66. And why maximum weightage is over here? In our case, I have already considered this data value 132, and 3 is the maximum value. That's why max is giving the output as 3, but argmax is giving the index of this, but softmax is giving the probabilistic weightage which is applied on the maximum value 3. Means after calculating the probabilistic estimation using all this formula which is mentioned over here, the maximum weightage is given over here. So actually we are getting the maximum weightage as an output for the softmax function. So this is the main consideration that you have to keep in mind. So that's why the output of the softmax function is completely different than other two max functions. So this is the basic concept. So what we have learned so far in case of activation function. So let's conclude these things. So here we have learned that whenever we are talking about linear and sigmoid activation functions, they are inappropriate for multi-class classification task. So for that purpose, what kind of activation function we are using? Softmax. Second point, so softmax can be thought of as a means softened version of Arg Max function. So whenever we are using the Arg Max function, the kind of meta interpretation we can say softer version of Arg Max is softmax function. And it returns what? It returns index of the largest value, this function. Whereas we are expecting maximum weights assigned to certain value in case of softmax. And now what is the third point? How to implement the softmax function? It is one of the most important thing to remember. Why? Because it is a probabilistic approach and always you have to remember this calculation. So this is the summary that what we have discussed. But whenever we have started our class, we started this concept from the activation function which is used in the hidden layer, right? And I have given you some kind of chart that is in hidden layer which activation functions are used for what architecture. So at that point of time, we have discussed some more conclusions. That is, first thing you have to remember, whenever we are talking about activation functions, they are the key part of the neural network. This thing we know because activation function has its own implementation or own implementational importance in case of neural network design. Now, whenever I'm talking about default activation function for hidden layers, then we generally prefer to use ReLU function. So except the RNN, all other neural networks like CNN, feed-forward neural network, they prefer to use ReLU function in the hidden layer. So this thing is also discussed. And the third point, the activation function for output layer. So whenever we are talking about output layer, it depends on the types of prediction problem. So the final conclusion is whenever you are going to implement the activation function for the output layer, first think what kind of task you are performing. Whenever you are using multi-layer kind of classification, say you are not using any binary kind of classification, 0 or 1, you have two classes. No, whenever you have multi-class classification, then you will prefer to use softmax instead of sigmoid or linear activation function. So the two conclusion always you have to keep in mind, activation function in hidden layer depends on the ANN architecture. However, activation function applied on output layer depends on prediction type. So this is the final conclusion of today's class. So here I have designed all kinds of possible activation functions. You can pick any of the activation functions from here and can use in your neural network code, any activation function. And you can get a good perspective of the activation function because the plots are also given. And in general, in the interview, the difference between tanh and sigmoid function is asked. So at that case, you have to remember both look same, but the only difference is the range 0 to 1 and 1 to -1. So this thing you have to keep in mind, right?